over the last day and a half or so. Couple of things before we start. Can I say a very appreciative thank you to Jim Heck and David Johnson for managing to slot this presentation in very last minute. I only decided to come to the Colloquium a few days ago after talking to Michael Johnson and him suggesting that it might be a great idea. Secondly, I'm a very nervous presenter, so you'll just have to bear with me. So I'm here today to talk about the East Anglian Amateur Radio Observatory. It's a very exciting project which is happening in Hertfordshire, not very far from here. I created the idea and I'm one of the directors. So our mission is to establish and provide a working radio observatory with its key objective to encourage young people to pursue STEM subjects and careers. So these are careers within the science, technology, engineering and mathematics subjects. We started the project, or I dreamed up the project a couple of years ago. Pretty much everything is ready to go. We already have a registered charitable company. We have a very enthusiastic, dedicated, small team of people. We have a huge amount of extensive specialist equipment, a solid research programme, academic collaboration network. We have a project website. We've already started on some STEM outreach concepts. We're very lucky to have a host within the University of Hertfordshire on their University Observatory site. We now have some bespoke radio control room modules which are ex-army from the Gulf War, which were donated quite recently, and included with those are some hydraulic gimbal-mounted dish antennas. This is really just bullet points for things that we already have to show you how close we are to actually moving on to our site and doing some science. We're still hoping that we're going to be able to get onto site towards the end of the summer and actually start building some stuff. So a little bit about the concept. I founded EAARO a couple of years ago. I have 22 years experience in technical engineering, and I'm keen to contribute some of my knowledge and experience that I've gained during that time for the benefit of science and technology. So my dream really was I've had a really exciting career, and I wanted to put something back into an industry that's been really good to me. And the way I decided to do this was by building this observatory to encourage younger generations to follow in a STEM-related career. I've kind of put my money where my mouth is, really. In the 2 years that I've been setting up the project, I've not gone to anybody cap in hand asking for money. I've funded the whole project from my own pocket, which currently stands at about £10,000. Pretty much every penny I've got has gone into this because I really want it to work, and I think it's just a great concept and a great idea. So just a bit about the history of the project. I came up with the idea. This is a way of just showing you how quickly things have moved. I never really thought that things would move on so fast. But I came up with the idea in September 2011. In January 2012, I began to look for suitable sites to build the observatory. In March 2012, we approached the University of Hertfordshire. We started having discussions with Hugh Jones, who's the director for the Centre of Astrophysics, about using Bayfordbury Observatory, which is the University of Hertfordshire's optical astronomy observatory, as a possible site. I went and did my STEM ambassadors course in April last year. In May, we decided to become a charitable company and register with Companies House. And by December, we already had an agreement in principle with the University of Hertfordshire, pending further authorisation. Yep, we'll just move on. So now looking this year, it's confirmed now definitely that we're going to be at Bayfordbury. We're currently, myself and my colleague John Blay, we're in the middle of writing an MOU, Memorandum of Understanding, with the university to get terms agreed for how we fit in on the site. We've been invited to various events. We've got some really interesting people that have joined our academic collaboration network. People like Professor Paul Davis at the University of Arizona, Jeff Lishman, Radio Astronomy Supplies, Jeff Lashley from the National Space Centre has just joined our team as our engineering advisor, chief engineer. Professor Mike Garrett, who's the General Director at Astron, has been a real big support and a real good source of advice. And then Tom Lyons from the EAARO office also has really helped us. And actually a couple of weeks ago I was at the EAARO conference presenting this same project to about 80 plus science teachers who were very excited about what we were doing. My colleague John Blay joined the team about 6 months ago, and he's now registered as a STEM ambassador. So we've had all our CRB checks done, and we can actually take some outreach projects into schools, and hopefully schools will be able to come and visit our observatory once it's built. So just going back to really what our key objectives are for the project. The main one, to observe and explore the universe through the medium of radio astronomy, to enhance and support science, technology, engineering and mathematics, teaching and learning in the east of England, where our home is, promotion of radio astronomy to a wider audience within the local community, and the establishment of a working radio observatory, providing a level of access to all who are interested in the universe and how we observe it. We're also very keen to assist the scientific community with their own research. We're going to be working alongside the University of Hertfordshire to provide them with additional resources that can coexist with their current observatory facilities, so it really has some mutual benefit there. We also think that we'd like to carry out some useful research in the field of radio astronomy, especially in the design and engineering of new telescope systems, and really just to be a source of inspiration and excitement to anyone with an interest in observation of the universe. So our team at the moment is a very small core team. Myself, my colleague Jonathan Blay, who's here today, who I think is going to get up and say a few words towards the end of the presentation, and Jeff Lashley from the National Space Centre in Leicester, who sadly couldn't be with us this weekend. And then just to reiterate some of the advisors, some of the people that are helping us with our project. We know we can't do this alone, so we've gone out and sought advice both in academia and in industry. This is some of the proposed observations. We haven't got the resources that places like Jodrell Bank, Mullard, Shilbolton have. So we realised that to start developing our observatory, we wanted to make some very basic observations, but doing them very well. So these observations that you can see here are observations that many amateur radio astronomers do, that require very simple antennas, very simple receiver systems, solar observations, Jupiter observations, listening to Jupiter noise, doing some meteor scatter work, hydrogen line observations, ionospheric, listening to VLF frequencies reflected off the ionosphere, measuring signal strength, and some future observations that we decided we wanted to strive towards in pulsars and black holes. One of the prerequisites of us being at the University of Hertfordshire site was that we did some meaningful research. We spent quite a while trying to find some meaningful research that we could do with our very limited resources, and these are the three sort of key research ideas that we've come up with and that we really want to pursue. I'm not going to go into too much detail about them because I haven't really got a lot of time. The first one, electrostatic effects of Martian dust storms, is all about how dust storms and dust devils behave in Mars's atmosphere, and the fact that charged dust sticks to solar panels and becomes quite a problem for satellites and space probes, etc., rovers, that kind of thing. So we're hoping that we're going to be able to measure the electrostatic effects and help NASA with their research about how to predict where these storms are going to occur. The solar coronal heating by electromagnetic reconnection, it's an awful long word. Basically, we're trying to investigate this mystery of why the solar corona is at the same temperature, sometimes hotter than the surface of the sun. And we think we'd like to pursue the avenue of electromagnetic reconnection. So this is where there are many magnetic fields that surround the sun. Sometimes these magnetic fields reconnect, and at the points where they reconnect, we think that flares are produced. We're going to measure solenoids at spot frequencies across quite a bandwidth and see if we can find any patterns there that might help to prove this theory. And the other one, which is probably quite interest to the Colloquium, is the behaviour of space debris in low Earth orbit, which is actually the KickSat project. So we're working alongside Zach Manchester at the University of Cornell, and the Space Design Laboratory there are working on how space debris behaves in low Earth orbits. So the KickSat project was actually born out of that research, and the idea is that eventually, once phase one is complete, and these, obviously Andrew's spoken quite a bit about the KickSats, but once phase one is complete and we work out how we can actually track and receive these Sprite spacecraft, the second phase will be to send another batch up with sensors on and start to begin to see how these very, very small nanosatellites, for want of a better word, but behave in low Earth orbit and how they move around, how they group with each other and cluster, that kind of thing. So we've amassed a huge amount of professional grade equipment. Most of it is used equipment that we've just scoured for basically car boot sales and eBay. So we have a large amount of signal analysis kit, we have a lot of receiver transceivers, we have antennas, we have some time standards, frequency standards, some data processing, low noise amplifiers, that just give you an idea of the sort of kit that we've got. Here's a small selection of some of the kit that we've amassed for use in our observatory. This is actually where we're going to be sited. A lot of people over the last day or so have asked me how radio quiet our site is. I just wanted to show you, let's just find the laser pointer. So this is Bayfordbury Manor here, and this is where this circle is the observatory site. So you can see it's surrounded mainly by fields and woodland. There are no power lines, there are no railway tracks, there's no industry, there's a very small amount of dwellings, there's a farm here, there's another farm at the back here somewhere, and just this is domestic dwellings now. This manor house has been split up. It's an absolutely beautiful place to conduct radio astronomy. It's in beautiful rolling East Hertfordshire countryside. You're surrounded by lakes and duck ponds. It's just absolutely beautiful. If nothing more, once you've been and visited the observatory, there are some beautiful walks around the woodlands. It's just we couldn't really think of a better place to be based. This shows just the Google Maps view of our site. You can see the optical observatory is here. This is the Patrick Moore building, where it's basically like the control centre for their optical elements, and we've been given this site here at the back here. Where you see these hash boxes, this was originally going to be our accommodation in a couple of 20-foot shipping containers, a bit like what the Loafer project are doing. And where you see these crosses, these are rough locations of where some of our antenna masts are going to be located. But it's quite a generous bit of land here. All our power and internet is coming from this building, and we're very lucky that the university have decided they're going to make electricity and internet available to us free of charge, which is so we're basically getting a plot of land, we're getting security, we're getting all the resources that come with being a part of the university. But they've been extremely generous. This project couldn't happen without their generosity. This just shows you some of our ideas about antenna masts. The YAG at the top here are part of an interferometer. These are some dipole arrays for Jupiter noise work. This just gives an example of a VLF antenna for people that don't know what one is, for our ionospheric measurements. Again, an example of a mast. You have to remember I was at an EAARO conference a few days ago, and some school teachers don't know what an antenna mast is, so gives people an idea. Just another satellite here, so another slide here, just showing the CubeSat and the way that the Sprite satellites will be deployed. Again, this is our site at Bayfordbury, just showing you a bit of the area. And this is the Patrick Moore building, so we're actually the other side. So the optical observatory is here and we'll be the other side here. And this just shows the outlook onto fields and woodland. And then just recently we were very lucky to be given a pair of these what are called BDIs. They came from the Gulf War. They were decommissioned in 2003. They consist of a control room and a scissor-mounted platform with a dish. We've been given a pair of these. They were originally designed to sit on the back of a 4-ton DAF truck. There were 3 of them. The third one got bombed. The other 2 survived and were brought back to a company in Hitchin, where we live, who basically sell surplus equipment on behalf of the Treasury. And they were told to either sell these or destroy them. So rather than destroying them, we asked if we could have them for our observatory use. Just shows you a close-up with the dish. These are quite interesting dishes. The dish aerial is on a rotator for circular polarisation, and they're very good over a wide bandwidth. I think somewhere between about 1 and 11 gig. So we were thinking that we might actually use these as our satellite tracking antennas. This shows you inside one of the control pods. A lot of the electronics now has been stripped out. On this side, the processor rack, a lot of this was still classified technology that we had to remove. But all the control circuitry and control electronics for the platform and the dish are still in place. There's a nice generous bench here. There's an air conditioning and a heating system down the bottom. They're pretty much ready to go. You know, we can just plonk them down on site, power them up, put our Rojo kit in and start using them. So we're really pleased to have those and to have them donated for nothing. Zach Manchester, who runs the Kicksat project. And that's pretty much it for the end of the presentation. Just before we finish, I'd like to introduce my colleague John Blay, who's going to tell you a little bit about his background and tell you just a little bit more about the project.
Hello, I'm sorry I'm a little bit less well prepared than Jason, but just a very brief introduction. I guess I'm wearing 2 hats slightly because I'm working with Jason very closely, but I'm also working on my own project. But my background is marketing combined with engineering, with a particular focus on technology innovation and the management of innovation. It's a personal sort of passion of mine. So I'm keen to encourage people to go into the STEM subjects and to STEM careers and to encourage innovative technology developments. With a marketing background, I'm also interested in encouraging the sort of public outreach or working in public outreach and helping your activities, for example, in terms of boosting the marketing profile and encouraging people to get involved. Just a word on my own project. It's involved, there's quite a long history to it. It goes back more than 10 years. In fact, it almost goes back about 25 years. But for about 10 years or more, I've been working on computer simulations of certain physical phenomena, including relativistic effects. And I'm working on a mission proposal for a test of relativistic effects, which could be done in low Earth orbit as a possible payload. So this is something that I'm hoping that Jason and I can work together on as well. And maybe it's something that could be of interest as an AMSAT project. That's about it, but I'll hand back to Jason. If there are any questions, I'm sure we'll be delighted to handle them.
Thank you very much indeed. Okay, yes, any questions in-house before we look online? No, none at all. Any questions on the internet? Oh, sorry, where was that?
as it happens, I know somebody who's very heavily involved in amateur astronomy in your area, the ex-chairman of the Letchworth Astronomy Society, Jerry Stone, and I shall be, if you're not in touch with him, I will put you in touch. How are you working with amateur radio clubs and with amateur astronomy societies? Because I think you could get a lot of support from those, both in terms of personnel and even finance.
I think because it's a community project, our doors are open to welcome anybody who wants to get involved. I have spoken to the Letchworth Astronomy Group. They were very interested, very keen to get involved, and I said that it would probably be the best time for that to happen is when we're actually on site and we start building. But yeah, we're happy for anybody in the community, anybody, you know, going back to my objectives, anyone who's got any interest in radio is more than welcome to come and get involved.
Thank you.
Right, excuse me. Well, Jason and the team, thank you very much indeed. I think, excuse me, I really admire the enthusiasm, and especially in terms of defending yourselves, and that is a marvellous thing to see these days, especially when we're in such a difficult time, to see people putting their money into this. But it also falls in what we were talking about earlier, the stimulus to education, and even looking back and reviving things that perhaps happened in the past. I have a personal interest myself in some of the things you're talking about, because I have, as an individual, and not as a company or anything, been looking at the impacts on HF aspects, earthquakes and the worldwide weather at the moment, and I've found out some amazing results, which I thought with the satellites we can measure it. This recent change in the weather we've had, yeah. And if you look at not what was up there, but was what below you, the reversals that's going on, and the earthquakes and the number of volcanic eruptions. At the moment, the chain that's going right through Europe is really a bow wave, and I don't know whether that's part of why the weather changed as well, but it's also associated with itself. I mentioned that I do a lot of special event stations, and I've noticed on the HF suddenly things that happen which we've never had experiences of before, like inter-Gs, and at the same time DX coming in. And then in the last few weeks, the noise levels, the noise floors have actually blocked out the HF bands, and it seems to be associated with all this arrival, as I said, of all this earthquake and noise that we're getting for Europe there. But it's just an interesting point, but I think I like to see these things happening, because we're still on a learning curve, and we look back as amateurs and what we perhaps got from our pioneers who didn't have the tools and they didn't have the satellites to do the work. And it's nice to see you doing it. But thank you very much indeed, and thank you very much.